Hey everybody, somebody give me a 5 for 5 and we'll roll right through. Thanks for being here, guys. Who gets the cookie today? Cecil Thomas gets the cookie for being number one. Heck yeah, baby. Thank you, Butterfly, Mary Miles. Good to see everybody. Anna, what's up? Mark Matheny, good to see you. Blade Hunter, George, Lisa, S. Nort, Murph Dogs in the house, baby. What is up, Murph? Good to see you, bud. Brian, what's up? All right. So, hey, what's up, YZN? All right, guys. 5 for 5. All right. Thanks to all my mods. Thank you guys. Everybody knows the mod, all the chat rules and all that. Please share it out. I'm going to say that every time I start my video. But that's the biggest and best thing you guys can do for me is share it out. We are starting to grow a little bit more again. Thank God. That's really what I've been trying to do is build this up some more. Got some goals for this year that I'll go over in a different live stream. But we're going to be starting memberships up this week and those kinds of things. I'm really going to concentrate on, on the channel and you guys. So thanks for taking this journey with me and all you guys from the beginning. I can't tell you how much I appreciate it. It's been 5 years, guys. 5 years. I can't even believe it. I've made 950 videos. So, yeah, that's a lot. There's people out there obviously do a lot more, like Mark Pyers. He's 1,800 and some days live every day. Never missed a day. Pretty impressive. And Tommy, he live streams about twice a day. Johnny not live streams, but does videos a couple times a day, sometimes 3. So yeah, there's a lot, some other people that do a lot more live streaming and video posting, but what I do, obviously I'll come on here if I need to, but try to do once a day. So, all right, guys. So we've got this. Let's see here. Yo, I was asking about Blade Hunter. Okay, let me see this. Got a question, guys. Is this caused by solar maximum, earthquake, black sun, or meteor shower and the sky splits apart? Please advise if this will be a solar maximum event. Solar maximum itself isn't actually an event. It's just a time frame. It's a part of the cycle of the sun. So, whatever your biblical beliefs are and things like that, everybody's going to have a different opinion in that. Hey, Ripper, good to see you, my brother. Good to see you. I was going to ask you, man, text me. Let me know if your son is back home or not. I was going to ask you that the other day and I forgot. But anyway, okay. Let's get into this, guys. I'm not going to squirrel anymore. I'm not going to look at the chat until I'm done with the space weather. Okay, so what we got here? This is Soho, okay? And it's this satellite right here out in front of Earth. It's from our point of view. It's 1 million miles closer to the sun than what we are. Always looking at the sun. So, that's a black occulter disk. That disk is on the camera. It will not go away. It's there. It's a physical part of the camera. It blocks the main part of the sunlight so it can take an image. All right, so there's that. Now, you're seeing multiple eruptions. And what we consider a halo eruption is when we see the eruption itself kind of poke out around the whole thing. If it's not poking around the whole thing, we'll call it a partial halo. Or sometimes there's no halo at all because it's not coming at us or directly behind us. If they get fired off to the side, typically you won't see any kind of halo signature. But I showed you guys a part of the sun yesterday on SDO that was kind of like lighting up, like I was showing you guys how it was kind of traveling across the sun. And we'll take a look at that again. But there was an eruption from that, and that's this halo eruption I'm getting ready to show you, okay? So let me, let's just pause it right about there, okay? So I'm going to back it up here, And I'm going to show you what a halo eruption looks like. Okay, see how it, you don't really have a whole lot of haze. Now this one is kind of going at an angle this way, right? So we can't tell if it's going back away from us, towards us, or directly to the side. You just can't tell from this one point of view. So what we're looking at here is this kind of faded signature. So I know, just because I've already looked, this one is actually going off the backside at an angle. And I'll show it to you on the CME tracker here in a few minutes. But this is not the eruption that we're talking about. So if I go forward again, you're going to see, and a lot of people are going to miss this one. Okay? People that do space weather probably aren't going to miss it, but most people would not see this because it is difficult to catch. Okay, you guys see that little bit of a, all the way around here? It almost looks like it's a distortion in the imaging. So let me back it up again. That, my friends, is a faint halo signature. So when we see those, we know that something's popped off the sun, and we see it starting right there. We know it's either going directly away from us or coming directly at us. How do we know that? Well, we know we can't see through a solid object, right? Like this occulter disk. So when we see that energy poke around like that on the halo signature, it has to either be going the opposite direction or coming right at us. There's no other choice there. It's not going to the side, this way or that way. If you don't see it anywhere else and all you see is this faded halo signature, we know that it's either coming this way or going the other way. That's just the way that the imaging works. So as I go forward there, you can kind of see how it pops out. Now that right there is the big eruption that I showed you guys yesterday, okay, and the day before, frankly. And again, guys, I will say this, I think we kind of got lucky with that one. I don't know that we wouldn't have had any issues from that. I think that we probably would have. And that's what I'll say on that. I'm not saying we would all lose our power or grid down or nothing like that, but I do think we would be having a different conversation. We could be talking about some electrical issues, some outages, other places, just weird electronic stuff, an uptick in earthquake, seismic activity, aurora increase. All those things happen with the CME, right? And that's exactly what I expect to see, minus the power outage stuff and all that stuff from this halo. Okay, this is not going to be a massive hit. Okay, so there it is again. I'm going to back it up. We're going to take a look at it one more time here on seeds. Okay, so just kind of, sometimes it helps if you like stare at this occulter disk. Hey, Ilea, good to see you, girl. And everybody else in there. I'm trying not to look at the chat. I'm sorry. Anyway, if you look at the occulter disk and kind of let your eyes kind of go out of focus, sometimes you'll be able to pick that up better. Now, I know it sounds weird, but it really is an optical thing, okay? And really, that's the point of all these models anyway. They're trying to give us a visual understanding of what we're observing, okay? And what we can see and what we can, conclude from all of that. That's what these models are built for. So you kind of see this little bright section right here. See how it goes all the way around the sun? Now, watch as it moves out. Everything right here will move out pretty consistently, right? So that's another way to see if it's a halo. See it all moving at the same speed? Typically, if you got something firing off this side of the sun and that side of the sun, the other side, they're not going to be moving at the exact same speed. So you can kind of see that visually. So when it's all moving the same speed, we know it's coming from the same CME. Okay? So we know that came from a halo. And I do think it's probably going to give us a glancing blow. Okay? It could hit us directly. Regardless, it doesn't look to be very powerful. We're probably talking G1. I don't think we're talking much more than that. And NOAA hasn't don't have us under any kind of geomagnetic storm watch, but NASA is kind of disagreeing with NOAA on this one. Okay, NASA is showing that side hit, and it could give us, a chance for a low-level geomagnetic storm, a G1. Now, if things kind of go all whopper jaw and all that, yeah, it could get stronger, or it could mean nothing. It could be absolutely nothing when it hits. Our magnetic field may deflect it. Our magnetopause will just take it right on out. We may not even know it, right? So that's what I'm saying. Now, so this is NOAA's, okay? And that's that big flare from yesterday. And these are data dropouts, guys. It's only because the satellite, which is a GOES satellite where this gets its X-ray data from, it's in a position it cannot relay the data back to, back to the observatory or the college or wherever they're picking this, NOAA, wherever they're sending it to. I don't know where GOES puts their data back to, where they collect it from, the actual physical location, but it can't transmit it back, or the satellite can actually be in a space where it can't even get the reading. Okay, it may not be able to actually see the X-ray if it hits. So that's what these downward spikes are. I didn't know what they were at first, and I had to ask. And, that's the best thing to do. Ask somebody that you think would know. Don't just assume that that's something weird that shouldn't happen, because it's not the truth. It does look weird, okay? Obviously. That's why we ask a question. But once you understand what that is, we can move past that. We don't have to keep revisiting the same thing on that end of it, because we know what that is. They can predict when these things happen. They forecast it. They will tell you. So, like years in advance, if the satellite stays in the same orbit, we will get these same type of signatures on a cadence, okay, on a cycle. So, yeah. What I'm saying is, don't go all the way out in left field if you don't have to. That's all I'm saying, okay? And be willing to accept whatever it is. I get asked the question a lot, guys, what's this, what's that? Do you agree with this person or that person? You know whose side I'm on? I'm not on anybody's side, except for the side of whatever the truth is. I don't care where it comes from. If it's the truth, that's what I want to hear and see. I don't care if I don't like the person personally. I don't care if they're my best friend. If it's not the truth, I don't want to know it. I mean, that's what I'm trying to say, guys. I'm not picking sides ever. It just doesn't do anything for anybody. Doesn't get you forward anywhere. So, okay. So now we're going to go take a look at SDO. I'm going to show you where the satellite's at first. There's that figure 8 pattern it does. It stays over this same part of the planet all the time. Okay, I'm not going to go into big depth detail this time. I'm going to kind of back off of that because I think I waste too much time doing that. If you guys want to know more about how this satellite works, come over here to SDO. The link is in my description. Just know that this keeps its eye on the sun at all times. It's from our perspective. So we're going to go look at that imaging, and it's this right here. This is over here on ISWA. You can see the SDO imaging on the SDO website, the NASA website, or here on ISWA, or there's other places you can go see it too. It's the same data. They're just showing it to you. That's all that is, okay? So you're looking at extreme ultraviolet, and that's a part of the light spectrum we can't see. All right? We see very little of the light spectrum. This is the 171 angstrom. I'm not going to spend too much time showing you this one because it's just not pertinent to what we're doing today. But I highly encourage everybody to go check all these out themselves. You'd be doing yourself a favor. I promise. It's, first off, it's neat stuff anyway, but all right, let's do this. Okay, so we'll just run this through. We'll watch and see what we can see. I don't think we're going to see much today because this is not on the 10th. This is the 11th. We didn't have much going on today, guys. Not from the sun, okay? So what I'm going to do is I'm going to take you guys back to the 10th. Now, this is the 304 angstrom. It's ionized helium. And I'm going to mention this too. Ben Davidson did a Suspicious Observer, did a video last week talking about what gases show up in these angstroms, okay? It's a very short video. It's like 2 minutes long. I wish I could get to that point where I was, that concise and still be able to explain it. And it was very well done and right to the point, and it tells you exactly what gas you're looking at and why we look at those gases. So please go check that one out. I really do recommend everybody go and check that one out. Let's go check it out over there, and he explains it really well. But anyway, so this is ionized helium, and okay? This is the most updated version. Now I got the same imaging here also, but this is back on the 10th, okay? This takes us back, and I'll be able to show you exactly where this halo eruption came from, okay? And I'm using this one, and typically I wouldn't use this one to see a halo eruption, but I am this time because it's almost like a stealth CME, and a stealth CME is exactly what that sounds like. It's a CME that people missed. We didn't see it, and it still hits, okay? So if you guys remember, I was talking about this area right here, right? Remember how I said it kind of lit up like electricity going across the sun? So let's see what we got here. Got to go that way. Oop. Okay, hold on a minute, guys. Sorry. This stupid thing, I hate it when it does this. Okay, here we go. All right, so we're going to be looking in this area right here. Okay, do you guys see that, right? Now remember, I'm going to go ahead and take this backwards a little bit more. Okay, so the big eruption the other day was over here, right? Well, watch right here. We had a smaller eruption, and I mentioned this yesterday. So watch this thing kind of light up. Right about there. See it get bright right there? See that? Right in here. And you can kind of even see this whole side of the sun kind of lit up a little bit on this imaging. So that was that flare yesterday. So that flare produced a flare, but the CME halo part of it came from up here. So to me, it looks like the flare happened, and then it destabilized this area right here, and it went ahead and erupted out some plasma. Okay, which is what we call a CME. We back it up a little bit more. Okay, and I'm going to take it slow. You guys see that? I know you do. I want to make sure everybody understands what we're looking at here. And I also want to point out, guys, there was another large eruption on the backside over here. Okay. See that? Now, we can't see exactly where that came from, but it is interesting that the Mars rover can look at the backside of the sun right now because of where Mars is in its orbit, okay? So it's looking at the opposite side of the sun that we see, which basically means Mars is kind of almost 180 degrees the other direction. but it's seen two big sunspots on the backside. And we'll go over that here in just a little bit, okay? But yeah. Oh yeah, guys, I forgot to mention too, we're going to be, I think I did mention the memberships. Yeah, so just want to make sure I want to mention that. People keep asking me that question. That's why I'm mentioning it, okay? And I am working on that. I'm waiting on one more thing. I've been waiting on one more thing for like a week. It's crazy. But anyway, see that right there? That's another large eruption that happened on the backside. And we can't really tell how big it is. It's not going to affect us whatsoever. But I just wanted to point that out. But know that that halo eruption was right here. So to kind of sum up that part of my live stream here, I'm going to back this up. This is Soho, okay? This satellite sits 1 million miles closer to the sun, always looking at the sun. Our perspective, okay? So again, watch this. There it goes. See that kind of get bright right there? That's the halo eruption. See how it kind of just stayed the same speed and kind of spread out? That eruption came from here. And it was hard to see. Why is it hard to see? Well, because the sun's actually camouflaging our view. Okay? So keep that in mind. So, you know, if this happens on the limb, the darkness of space is black, right? At least on this imaging. And if it fires off this direction, we get a good contrasting view of it. When it fires off right in front, we got two obstacles here. We got the sun itself kind of camouflaging things. And then, if you go look at seeds, we got this occulter disk in the way. So, this is why sometimes these things are kind of difficult to get a good, you know, a good peg on these things. Especially when you got multiple eruptions happening. There have been a lot of filament eruptions, okay? I mean, a lot. So, this is the same imaging, okay? This is on the SDO website, though. This is over here at the nasa.gov website. And it's the same imaging. It's just you can do it in time frames back further. You get to see more imaging in one movie tool. This is going to give us like 3 days of stuff if we want to see it. The one over here on ISWA only gives you 300 images at a time. Now, you can still go back and keep clicking 300 views and all that stuff, but it takes too much time. So, we're going to look at it here. So, let me play this. We'll slow it down just a touch. Okay? So, I'm showing you this, the full view here, because I want you guys to understand what the sun's actually doing the past couple days. The sun is just erupting all over the place. It really is. Surely is. Piper Lynn, you got yourself a wrench. So you know. I thought you already had one. I'm sorry. I would have given it to you a long time ago. Mods, welcome her to the mod family. Guys, give me a roll call in the chat, would you? I'd like to know where you guys are from. This regional, I think it's pretty cool because, you know, I see Sturkeister Creations talking about a power outage where she's at. She puts her location in there. Hey, Hilly, Central Alabama. Okay. Probably not Sturkeister, not this time. I don't think that would have anything to do with the power outage you're experiencing. But yeah. All right. So let's watch this again. Now I'm showing you guys this because it's it's pretty impressive what the sun is doing. And I know that it doesn't look like a whole lot. Okay. I get that this isn't like exploding in your face like what we get over here when things happen, you know. But the fact of the matter is, it's very active. So this is just more intense visually. That's the only reason why I'm bringing it up. So, you know, there's that big eruption. We don't get to see that kind of dramatics over here. Now, we will see it sometimes when it really does have a big one, like over here. Watch. It's just going to pop out. You'll see it. Obviously, I already showed it to you guys. But there's one down there. Now one up here. These are all filament eruptions, guys. These are dark, snake-like strings of plasma laying on the surface of the sun that destabilize and lift off. And eventually they snap like an incandescent light bulb. An incandescent light bulb has a filament in it that's curled up, looks like a spring right in the middle. You pass electricity through that, they curl it because it causes resistance. That resistance will build heat. That heat will then produce light. Yes, that's a little bit of a whatever for a light bulb, right? Explaining how that works, maybe a school type of setting. I don't know. But what I'm saying is that's how a light bulb works, right? With the filament. When the filament breaks, the light bulb goes out because you break that electrical connection. It can no longer complete the circuit. So the same thing happens magnetically with plasma on the sun. Plasma is a charged gas. It follows these magnetic connection lines. It travels on those lines. It will not come off of those lines. It doesn't happen, right? So, yeah, you can have, obviously, particles without these lines. But I'm saying the plasma that we see is traveling on a magnetic connection line. And when that line breaks in the middle, or wherever it breaks at, it snaps off like that and shoots plasma out. Now, sometimes the sun will recapture it. We call that solar rain. And we see that in this imaging. And I'll show it to you here. I'm going to slow this down a little bit more. Okay. So, I'm trying to give you guys a pretty good look at it here. Now, the big eruption that happens over here, you can actually see a lot of it go out into space. But then you do see quite a bit of it kind of spiral and come back. See right there? See how that all kind of looked like it went back? It did. There's another looping arc of plasma traveling on a connection line. All that is what we call, and we call it solar rain. But it's nothing more than the plasma particles traveling on that magnetic connection line. So here's a filament lifting off right here, and then boom, there's that big one. So anyway, I just wanted to show you guys that one again because it was impressive. In my opinion, that could have been one of the biggest ones we've had this sun cycle. We just will never know because it's on the backside. Okay? This is discovered data. I'm not going to waste a whole lot of time here, but we are taking some sort of a geomagnetic hit right now, guys. Okay? Either that or this model is not updating correctly, which is a possibility also. See how we're kind of getting zeros from time to time here? So I don't know what's going on with that, if it's a collection issue here or something, I don't know. But what I will say, our BZ, we look for -6, right? That's the magnetic polarity position. Basically, it's the magnetic position of our magnetic field, the direction of it. And when it's a certain level, it does certain things. Hold on a minute, guys. Sorry, I got real life. Avery, can you please? I'm live, so. Sorry, guys. My dog was in my face. Sorry about that. Anyway, so let's go ahead and move forward. This is the this is the magnetosphere movie. And what you're looking at, the sun is off to the left. The sun's off to the left, and it's shooting energy from left to right, right? All the stuff's coming that way. So you see velocity right there. Hey guys, I deal with real life, just so you guys know. So please don't judge me on that. I got a family, and that's just what happens. My dog just woke up, and she's still a puppy. She's a little over a year old, and yeah, so you know how that can be. Jack Russell Terrier too, so they kind of get a little lippy. But that's the velocity, okay? You can see us taking hits. Look at that. See our bow shock? Now, does that mean that we're taking a huge amount of stuff? No, it doesn't. Okay? And I want to say this, if they're having issues with their data, it can throw this off too. Okay? This doesn't look like a mistake. I will say that. This looks like it's something that's actually happening. Okay? And so, yeah. So that's what's going on with that. Now, this is density. Density only. This is the bow shock. That's the first point of contact to space weather and our magnetic field. All right? So you see how it kind of deflects. The lighter color is lighter density. Just is what it is. All right? Now, if we go down here and look at magnetic pressure, what are we looking at? We are looking at some magnetic pressure increases. See how we got hardly anything? Now watch when this stuff starts to hit. You're going to see it build real quick. And this probably was some sort of a glancing blow from a weak CME. We've had a bunch of those that had a chance of kind of clipping us, but they were very weak. Notice how thin that is? Okay, so let me pause it. Take it down here when we took the hit. See that? So it's doing exactly what we want our magnetosphere to do. It's taking the hit, absorbing it, and deflecting it away. Okay? So that's exactly what it is. That's what's happening right there. So, yeah. It's just confirmation of what Discover data was showing us. I don't want to stay on this graph for too long because I know it bores people. But when I see zeros over here, in between consistent data points, it points to that they may be having some issues with collecting the data. So if this data is not correct, this is not going to be correct because it gets its data from there. It inputs that data into this model. So always keep that in mind. But this doesn't look like a mistake. This looks like something that is probably actually happening. Okay? Typically, we'll see little strange things on this when it's jacking up also. Okay? This is the German website I show you guys. This is the same way that we look at geomagnetic conditions over here. These are 3-hour data points, though. They're averages every 3 hours. Over here, we get 30-minute. So it's more real time. It's the same data. It's not the same data, but it's the same. They use the same indice to measure it. Okay? So, but this is 30-minute averages instead of 3 hour. So we get a better gauge on what's exactly happening now. Oh yeah, guys, I want to give a shout out to one more shout out here to Aaron. You know, he's super chatted quite a bit and left me a lot of super thanks. I just got to shout you out again, brother. Thank you for doing that. It really does help. I just want to make sure that you're recognized for doing that. It's awesome. And everybody else is super chatted. It helps so much. I do appreciate it. It's never expected, but it's always appreciated. So, but I did want to point out Aaron because he's helped out a lot lately. So anyway, guys, we'll move forward from that. Now, let's go to spaceweather.com, Dr. Tony Phillips' website. He's actually talking about the sunspot being seen from Mars. The rover's there, right? The rover has a mast cam. All right. It's seeing 3 far side sunspots right now. 2 of them are big, right? So if we click on this, I don't usually click on the links because I want you guys to go give them some love. So please do that for me. Go over to spaceweather.com and give Dr. Tony Phillips some traffic over here, okay? So this is from Mars, and this is from the Mars rover. It's seeing the backside of the sun. Why is that important to what we're talking about? Well, because eventually this is not going to be the backside. It's going to rotate in towards us. And we have an old sunspot that was very, very active on the front side that is now survived the backside and is probably going to come back around and look at us again. So that's why I'm talking about it. Not to mention that it's cool to see a sunspot from a different planet. It's kind of cool. On the big emissions that hit Mars yesterday. Oh, you talking about Mercury? The CME that hit Mercury? I haven't seen anything on that, if that's what you're asking, Tin Top. Hey, Joy. But I haven't seen any kind of massive data release on that, any kind of story on that. Guys, you guys can simply Google that sometimes, and you'll get somebody will write an article on it. But yeah, so here's that big M flare from yesterday. Hey, Ron, man, oh, come on now. Thank you. Holy cow. Thank you. Daylight savings time is dumb. That is all. I love it. I love it. Hey, let me tell you something, Ron. I live in Indiana, and our time zones, oh my gosh, because for multiple years, we didn't observe daylight savings time. So both states around us would change their times for daylight savings, and we wouldn't. I live on the border of Ohio. So you can imagine how confusing that gets. I literally can drive 3 minutes and be in a different time zone because of we didn't observe that. You know, we didn't observe. Yeah, yeah. Indiana's crazy, isn't it, Daryl? So anyway, with that time zone difference, it does kind of jack you up. You know, like holidays and stuff like that. Because my wife's family's from Ohio. They lived just over the border, and we would drive back and forth at Christmas time, and we'd have to take into consideration that because they were an hour different from us. So for half the year, we would have the same time, and then for the other half, we wouldn't. And a fun little fact here, guys, I know it's not really space weather, but it does kind of apply. There was a few years that there was such an argument here in Indiana that our state government got so upset that they let each county, listen to what I'm saying here, each county got to decide whether or not they followed daylight savings time. Can you imagine the crap that happened with that? I mean, literally driving from county to county, your time would change. It was so ridiculous. Obviously, they had to step back in and change that. But now we observe daylight savings time. There used to be a time zone called Indiana time. Kind of crazy. In case y'all didn't know that. Hey, Ron, you're awesome, brother. Okay. So, again, guys, and Dr. Tony Phillips here is kind of confirming what I said. Talking about the CME that popped off and is now the halo I just showed you guys from that flare. But it didn't come from right here. It actually came from up here, I think, anyway. Looks to have, anyway. But the flare kind of destabilized it, and it kind of popped off. So, it's all connected. I'll just say that. How about that? But it's supposed to be giving us a glancing blow. Could get low-level storming from that. Now, let me take you to the CME tracker, because I should have showed you guys this a little while ago anyway. I want to point out here That's that bigger eruption on seeds I showed you guys a few minutes ago. Okay. Also, Mars is over here. See that? So that lets us know that it's looking at the backside of the sun. That's why it was able to see stuff that we can't right now. So there you go. Now that again, that sunspot's not that eruption is not coming at us. But check this out. Well, look over here. Watch that thing. You see that? That is a significant eruption. It didn't look all that impressive on seeds, I have to say. Let's go over here to seeds and we'll take a look at it again. I'm not sure if it came from... Okay, now you guys see that one? That's another halo. Watch. Right there. You see that halo? Now let me pause it. Okay, now look. See that? That's going off the backside. That's not coming at us. So this looks very similar to what I showed you that is coming at us. That's why I'm showing it to you, because it'll give you guys an idea how hard this is sometimes to catch. So that's what I would say. But yeah, that's not coming at us. So I'll tell you what, just to confirm that, we can confirm that by going over here to SDO and looking. So if I back that up, I think there was an eruption down here. Okay, there's that eruption. Now see, I want to double check myself here too, guys. I don't want to give you guys the wrong info, and I always try to double check. I want to see if we see any other eruptions coming our way here on the 11th. Okay. I think that's probably up here. So that's on the 10th. So that's definitely not that eruption on seeds. So that right there, down here, is probably that eruption. Now, I will say this. If you look right here, we kind of had a bright spot up here too. So I can't really give you 100% on that, okay? So I'm not going to say one way or the other. But I don't think it's coming at us. I guess it could be. But regardless, when we see those things, that's why it's so hard to tell. It's either going the other way or it's coming right at us. That's just the way that it works, guys. Okay? So, all right, guys. That's the space weather report. You guys got any questions? And now I'm going to do some shout-outs because I'm saving it for the last. Hey, Aaron. Thank you, my brother. Daryl, Hilly. What's up, brother? Stephanie. Miss V's in the hizzy. Jerry, Daryl, Angel, Joy. Mahomes, Wrath. Supporting paper of what? I must have missed that one. The sun is a hydrogen helium electrified plasma reaction, not just a ball of fire. 100% correct. Yes, it is not a ball of fire. Okay. The Earth is the size of a grain of sand. Yep, in that aspect, in comparison to the sun, and even a small CME is many thousands of times the mass of this planet. Yeah. 100% correct. You are 100% correct there, man. But yeah, so all right. All right, guys. So thank you, mods, for handling things in the chat. I really appreciate you guys more than I could ever say. Wrath, thank you for understanding the mistake that was made the other day in the chat. It's been like 2 weeks ago now, but just want you to know that that you didn't do anything wrong there, and I took care of it. So just making sure you understand, and I apologize for you not being able to chat for a minute there. So yeah, you're right. It's a fusion, and I don't typically go into that, guys, because it's a big, huge subject. As Wrath will probably confirm with me, it's not an easy thing to explain to people, and some people have a hard time understanding how the sun isn't fire. You have to have oxygen for fire, number one. Yeah. Anyway, I'll just leave it at that, and I'm sure Wrath and a lot of you guys understand too that the sun is, first off, is not completely understood yet. For a long time, and they still are trying to figure out why the atmosphere is hotter than the surface. That's why they sent the Parker SP probe out there into the atmosphere of the sun. That's why they did that. First time it was ever done. They got some really good data from it, and they've got some really good solid things that they figured out from that. But there's a lot more to go here. Okay, we got a question. Cheryl. Hey, Mark, question. How likely is it that the gravities from the sun, moon, and earth and their positions during the eclipse could have an effect on altering the path of the comet? Probably zero. And the reason we're in a balance anyway. That's why we're in an orbit where we're at. Everything is already in place. If things were moving, in order for those things to not be moving the same way, it would have to be caused from that comet. And that comet is in no way, shape, or form big enough to do something like that. So, but yeah. I've heard that, Wrath, but I don't know a whole lot about it, so I can't really speak on it. I know what you're saying there with that. He says, he asked me if I've ever heard of a term called Brownian motion paradox. I've seen that, but I honestly really don't know what it is. And let me ask you this too, guys. Blessings, Brian. See you, bud. God bless. How many other channels you guys ever go to that'll sit here in a live stream and say, hey, I don't know nothing about that? Most people are going to sit here and blow a bunch of smoke up your butt so they sound smarter than what they are. Hey, Seven, good to see you, bud. Hey, guys, it's okay to let everybody say what they think in the chat, okay? As long as it's not being disrespectful. If it gets to be name calling and stuff like that, that's when you guys should delete it. But let everybody have their voice. I don't care if it's something that sounds way out in left field. It's okay. As long as it's not disrespectful and they're just voicing it, it's fine. Okay? Now, if they attack me, let that stay there. I don't care what they say. Let it stay there. Okay? Even if it's disgusting, let it stay there. Let me look at it, and most likely I won't even have to say nothing to correct it because everybody else can see it. It just shows how ignorant people can be when they start getting disgusting and mean. So, well, Bruce, we're not going to have an argument though, but yeah, it is. I could probably show you. I'll tell you what, Bruce, you come back tomorrow on my live stream, I've got a model that can exactly show you why we say that. That's one thing that I do here. I'm not going to say it unless I have something to back it up. I'm not just going to blow a bunch of smoke. That's not how it works. So I'm gauging by what Bruce, what you're saying there, brother. And it's okay to have whatever belief you have. Honestly, I truly mean that. Just let me ask, are you a flat earther? That's kind of what we get, those kinds of questions and comments from flat earthers a lot. Obviously, you know I'm not, because of, I mean, look at my channel. But yeah. But I'll tell you what, guys, I am going to go ahead and kill it for tonight. I got some stuff I got to get done. But I will be back tomorrow. Bruce, come back tomorrow. Hey, Nana, thank you. Thank you for being here. But come back and I'll show you what I got. And here's the thing, guys. You know, I'll say this, and I'll end the live stream with this. Let's just put it to you this way. I'm trying not, because it's hard to say these things with it not sounding like I'm trying to be mean. Anyway, I'll say this. Everything I show you guys, I have something to show you and back it up with data, right? I have models. I have tons of models. I don't have to use anything electronic. I don't have to use images to show you that the sun is 93 million miles away. There's mathematics and stuff that you can use to show exactly how far things are away. You do it by using angular distances and all kinds of other math, right? But I'm not going to say something unless I have a model that backs it up and can show it. And to this day, there is absolutely no model that will work for flat Earth. I'll just say that. The models I show you guys, it predicts. It can forecast things years, centuries down the road. It can show you what happened and prove itself years behind us. That's the kind of stuff. No, I'm not talking about computer models, Bruce. Not at all. I can get a globe and a camera and show you exactly how those things work. I don't have to use a computer. That's a fact. Math. Love it, Hilly. And I don't want you, Bruce, I don't want you to think that I'm offended either. I truly do support people having their own beliefs. I really do. So please don't think I'm coming at you here. When I see those kinds of questions, and obviously I'm not a flat earther. So, I mean, that's just like, you know, I want you to be able to have your voice here too. I want you to hear me also. So that's kind of what I'm saying. But I don't have to use anything electronic. I don't have to use any imaging from NASA, NOAA, anything. Let me say this. Do you think they had satellites and all the stuff back in the 16th century, 17th century, 18th century? No, we didn't have any of this stuff until inside of 100 years ago. So we were able to explain things without all that. Just explain how, what are you saying there, bud? Ejects huge CMEs, but they never face Earth. Yeah, they do. Yeah, they absolutely do hit us daily, almost all the time. We are constantly getting hit from the sun. And we get small CMEs. We get all those things happening every day. During solar minimum, during solar minimum, we don't get hardly any CMEs from the sun. Anywhere. So, I guess what I'm going to do right here, I'm going to end the live stream after I show you this. Okay? I'll tell you what, it'd be better if I just showed you over here. And I'm going to use this one because You can go outside yourself and put on a pair of eclipse glasses, and that's what you're going to see right here. This is what you will see, except it'll have like a yellow tint. Okay, you see this sunspot right here? From here to here is about 15 to 20 Earths wide. So just think about that. That's how big the sun is. And it can explode anywhere and everywhere at once. The Earth is that small. There's not just one plane we're talking about here. It has to match up horizontally, vertically, all of that. All the axes have to be correct in order for it to hit us. Not to mention that we do get hit a lot. We just don't talk about it because it is not big enough to talk about. You see this one right here you're looking at on the screen? All you have to do is go outside, put a pair of eclipse glasses on, and you're going to see the same picture without anything. That's what I'm trying to tell you. I don't have to use any of this. How else am I going to show you anything without turning my computer on? That's good. I mean, I'm not told anything. People say things and I research it. That's what happens, just so you know. And I will say this too. I know you haven't done this, but even if everything I've ever said is wrong, does not mean that you're right. I'll just say that. So if you're going to say that, why is it this, that, and the other? Why aren't we getting hit with CMEs? Well, tell me why we should. All the time. Explain that to me. If you want me to explain to you, which I attempted to very briefly here, without going into deep, and I'm not going to go like deep into this anyway, because it's just not, I mean, it's been talked about 1,000 times, and I'm not going to beat a dead horse. But if you're going to ask that of me, I'm going to ask the same thing of you. Show me what you think is truth, and show me why. That's all I'm saying. Just saying. And there's so many things, guys, and again, let me say this too, Bruce. I don't want you to think that I'm coming at you, because I'm not. I'm just simply trying to give you my side of things also. So there's so many things that we still don't understand. That's why we do science. And I will say this in support of what Bruce is saying here. We need to continually revisit things that we think is the truth and real science. We need to continually reprove and re-show and redo all this. But like I said though, you know, you don't want me to use any imaging. There's nothing I can do to show you anything here without using imaging. I wouldn't even be able to talk to you if that's the case. We're not standing face to face. So what I'm saying is, the eclipse is on April 8th. There's a ton of eclipse glasses out there right now. If you don't have that, get a piece of welding glass. And when you're looking at the sun, you're going to see this. So that right there is going to tell you that it's not coming from images. That's what you're seeing. So anyway, guys, this is getting kind of strung out. I'm not going to let the live stream go much longer than this. I really do have to go. So, but again, Bruce, come back tomorrow and I'll show you direction and why things miss and hit and all that kind of thing. If you want me to, I can. It's not hard. But anyway, guys, I am going to pop off. thanks everybody hanging out. And I do appreciate the conversation. It was respectful. So thank you, Bruce. Really, seriously. I love having those kinds of discussions. I think it's productive when it's respectful. So, all right, guys. God bless. The images yes, I have to. What else am I going to do? What else would I be showing you? Anyway, I'm going to move on. We can talk tomorrow. All right, guys. God bless. Yahusha saves, and you can drink this Kool-Aid.